The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon to everyone, and I'd like to welcome everyone to this second in a series of 5 webinars on pavement sustainability. My name is Kurt Smith, and along with Tom Van Dam, we will be serving as the host and moderator for these webinar events. We appreciate everyone taking the time to join us today and look forward to an interesting and informative session. Before we begin, I'd like to give a little bit of background on the webinar. This webinar series is sponsored by the Federal Highway Administration and focuses on the information contained in the recently released FHWA publication Towards Sustainable Pavement Systems, a reference document, which can be downloaded at the link shown here. We are presenting a series of webinars over a 5-month period that's intended to highlight some of the key and critical aspects of that reference document. These webinars will be recorded for later posting to the FHWA website. We are planning for the formal presentation part of this webinar to go for about 1 hour and 40 minutes in order to allow for about 20 minutes for questions at the end of the webinar. We strongly encourage your questions and ask that you submit your questions at any time during the webinar using the chat box feature found in the GoToWebinar widget on your screen. When submitting questions, be sure to access the drop-down feature in the chat box and select the Send Questions to Staff feature in order that we can receive and compile your question. Also, we would like you to note that we'll be providing 2 hours of professional development hours in the form of PDH certificate for each registered attendee. But please understand that these are different than continuing education units. You will want to check with your local professional licensure organization for applicability of PDH credit for your particular situation. As I mentioned, this is our second presentation within the webinar series. Several weeks ago, we presented an overview webinar on pavement sustainability and ways of assessing pavement sustainability. And today we're going to be focusing on sustainable strategies for asphalt pavements, covering materials, design, and construction aspects. Our speakers for today include Gina Ahlstrom with the Federal Highway Administration, Tom Van Dam with NCE, John Harvey with the University of California, Davis, Ahmad Al-Qadi with the University of Illinois, and Hassan Ozer with the University of Illinois. And again, my name is Kurt Smith, and along with Tom Van Dam, we'll be moderating this webinar. So now let's begin the webinar by hearing first from Gina Ahlstrom, who will provide some background information on FHWA's Sustainable Pavements program. Gina?
Okay, good afternoon. Let's see. Okay. So to start off, the U.S. DOT is committed to advancing sustainability in all aspects of transportation. Secretary Anthony Fox signed a policy statement in June of 2014 that demonstrates this commitment. We are encouraged to consider sustainability in our policies, operations, investments, and research. In 2010, the Federal Highway Administration established the Sustainable Pavements Program. The program goals are to support the US DOT goals for sustainability, increase the body of knowledge regarding sustainability of asphalt and concrete materials throughout the pavement life cycle, and increase the use of sustainable technologies and practices in pavement design, construction, preservation, and maintenance. The first order of business under the program was to define what sustainability means in terms of pavements and materials. It is necessary to give practitioners guidance and clarification on how pavements and materials fit into the broader concept of sustainability. The document Towards Sustainable Pavements, a reference document, is just that, a reference. It provides guidelines for the design, construction, preservation, and maintenance of sustainable pavements using asphalt and concrete materials. Its goal is to educate practitioners on how sustainable concepts can be incorporated into pavements, and it encourages adoption of these sustainable practices. What we're focusing on is what we can do today to incorporate sustainable practices into our pavements. The document provides a comprehensive review of current literature specific to pavement sustainability. We had an extensive review of the document with input from stakeholders. And rest assured, this is a comprehensive document that benchmarks pavement sustainability today and helps us look at improving and moving that benchmark in the future. With that, I will turn it back over to Kurt.
All right. Thank you, Gina. We appreciate that background. And with that, we want to now start moving to the main focus of our webinar today on asphalt and asphalt pavements. To begin with, we're going to have a presentation by Tom Van Dam, who will be presenting on materials and materials considerations of life cycle and aggregate materials. So Tom?
Thank you, Kurt. It's nice to be the beginning of the focus. I did want to remind a few people that they've been joining us a little bit late. If you do have questions, make sure that you do use the chat box to submit those questions. We welcome those, so please make use of that. Basically, I want to just begin by talking a little bit about materials and the consideration of the life cycle. The life cycle is really a critical concept when we look at sustainability. And so when we specifically are looking at materials, from that perspective, there's a whole series of questions, really, that agencies and those who are working for agencies need to ask. One of the first ones are, what are the agency's sustainability goals? And that's going to vary fairly widely. You know, what are the impacts of using a material once versus multiple times? Sometimes some materials are far more recyclable than others. What are the trade-offs in increasing the use of recycled, co-product, or waste materials? These are worth talking about in a little bit more detail. There seems to be some subtlety between the different types of materials within this category, and the subtlety, though, is important later as we consider analyzing the environmental impact of these materials using something like a life cycle assessment. A recycled material is one which is obtained from an old pavement and is included in a new pavement. And so a very common example is RAP, reclaimed asphalt pavement, or recycled concrete aggregates, in which we take an existing concrete and recycle it back into aggregate for a new pavement. A co-product is a material in which has from another process, but that brings value. These are often industrial processes. A good example in pavements might be slag cement, which is pulled off of the molten slag coming out of an iron blast furnace, and specifically processed to turn it into a cement for use as a binder. Wastes are materials that would normally be landfilled. So these would normally be just streaming towards the landfill, but that we can beneficially use. A very, very good example that's seeing increased use in areas which has a supply of asphalt shingles is recycled asphalt shingles, or RAS, where we can take these shingles, process them, and use the binder in the aggregate in a new asphalt binder. Something like fly ash in concrete, a little bit more complicated. Depends on region, quality of fly ash. It could be considered in some cases as a waste, but in most other cases as a co-product, as its value is greater than that of transportation and disposal. So when we look at the use of our RCWMs, you know, a lot of questions arise. You know, does this material bring equivalent or better performance? And that's a very common thing. What if the performance is slightly worse? That's a whole other consideration. Does the RCWM have to be transported great distance? And I think this is one in which unintended consequences sometimes affect us, where an agency might specify a certain percentage of RAP or a certain percentage of recycled material being present. If you have to transport that material 100 miles to get it to site, any environmental advantage of that material may be lost. And a matter of fact, it may be a negative. And does the RCWM make it more difficult to recycle in the future? And so sometimes as we bring in recycled materials in the next cycle, we may find ourselves in difficulty and how to address that in future recycling. Other considerations or questions broadly that we ask about materials, does the material increase construction variability? So as we stretch out and we look at different sources, more quote-unquote sustainable materials, is it something that we're not used to working with, or it's going to impact construction? Does specifying a longer lasting material increase transportation or production-related impacts? And then how do we trade that off? In other words, longevity has great advantages, but if obtaining that longevity requires big environmental impact up front, it might not work out as well as we would think. Are specifications a protector or of quality, or are they a barrier? Often we'll see many specifications that limit the materials that we can use, and these things can provide a barrier. But at the same time, specifications from an agency's perspective are protecting the quality. Does the pavement design make best use of lower impact materials? In other words, if our design system is all based on higher quality, more difficult to obtain materials, how can we bring in some of these lower impact materials into the design process? And are the impacts of transporting materials considered? And so we'll talk a little bit about that coming up. So switching specifically to aggregates, they make up the largest share of mass and volume of the pavement structure. We use a lot of aggregate in our pavements, and they have a relatively low environmental footprint per unit mass, which is a good thing, but because we use them in such large quantities, their impact is not negligible. So as we look at the aggregates, we look at the process of mining, processing these aggregates, transporting those aggregates, and really that impact to transportation can be very, very large, and that's becoming increasingly a problem. We use asphalt aggregates and asphalt materials and concrete mixtures, bound and unbound base and subbase. So basically anything above the native subgrade has aggregates contained in it. Natural aggregates are classified as being crushed stone or sands and gravels, and then manufactured aggregates are created really specifically to possess unique characteristics. And some of these can also be co-products, such as air-cooled blast furnace slag, for example, as an aggregate. Looking at just typical volumes, you can see that they differ for asphalt concrete versus hydraulic cement concrete. We have a bit more aggregate by volume within the asphalt concrete materials, but in both cases, a substantial amount of those materials are aggregate. Aggregates are produced in all 50 states. About 1.3 million tons of crushed stone was produced in 2012, worth about $12 billion. So this is not a small industry. And most of this material, the vast majority of it, goes into construction materials, or even 10% goes into manufacturing Portland cement. Less sand and gravel is produced at greatly reduced value, but still it's a very, very sizable amount of material. And so again, when we look at these materials, the impact of a ton of stone is not that great, but the volume or the mass of it is fairly extensive. So when we look at RCWMs used as aggregate, we have reclaimed asphalt pavement, recycled concrete aggregates, recycled asphalt shingles, air-cooled blast furnace slag, steel furnace slag, and foundry sands. And all of these can find a place within a pavement structure if used appropriately. When we consider impact, we primarily look at energy consumption and greenhouse gases. Depends really on the source of electrical power and transport distance. And so crushed stone has greater impacts than sand and gravel, We also will consider things like fugitive dust, water consumption, land use issues, community impacts, and all of these impacts really make it difficult to continue to mine or permit aggregate sources in urban areas. And this just shows kind of a general chart, energy consumption on the left vertical axis, global warming potential on the right. The general trends here that you'll observe is that crushed stone has a higher impact than gravels for any given source, and that the impact varies depending on the study and location around the world. This is what I was discussing regarding transportation mode. The one truth is that moving materials by truck is the least efficient way to move material ton miles per gallon. And so related to the fuel consumption is cost, but also environmental impact. And so if we can use inland towing or rail, we get a substantial improvement in efficiency. So strategies for improving sustainability, really we look at trying to reduce the use of virgin aggregate over the life cycle, reduce the impact of virgin aggregate acquisition and processing, and then really trying to focus on reducing the impact of transporting aggregates. And various strategies are discussed within the text. I think a good example is the Illinois Tollway. They have basically committed to 100% recycling of their existing pavements. They look at trying to replace their binder and asphalt mixes by 40 to 60% using RAP and RAS, and we'll hear more about that a little bit later. They use the fine fractionated RAP as a binder replacement, and then they're left with stockpiles of coarse fractionated RAP, which they're now recycling into concrete pavements in the bottom lift of a two-lift system. They use in-place recycling whenever they can, and the important thing to emphasize here is that decisions are first economic for the tollway, followed by environmental. And so although they're committed to the environmental benefits associated with the use of these materials, they're really looking at their economic bottom line. As we look to the future, our big challenges are proximity of aggregate sources to urban centers, trade-off between that transportation and the local impacts on the communities, increasing pressures to increase the use of these recycled, these RCWMs. There's a trade-off there with increasing use with performance of the pavement system. Increased use of marginal aggregates as premier aggregate sources become more scarce. And then the last point, demand for specialty aggregates increasing to meet specific sustainability goals. And that is it for aggregates.
Very good. Thank you, Tom. We are going to move on to our next speaker now, John Harvey. And John is going to be discussing different aspects of asphalt pavements, including materials, rehabilitation, and design. So, John?
Thank you, Kurt. Thank you, Tom. Good morning, everybody. So we'll be taking a look at asphalt material mixtures, design considerations, rehabilitation options, and discuss a few example strategies that intended to improve sustainability. The scope, first we're going to talk about asphalt materials and mixtures.